Okay, welcome everyone. Thank you for joining AI4 in this session. We are super excited. We have Marjan, Mazrouei, Sebdani. She's a machine learning engineer at Dun and Broadcast. Marjan, welcome. We're excited to have you.
Thank you. This is Sarta. Very good time to start.
Yep. So you can go ahead and share
Okay.
your screen and we'll be good to go.
Okay. Hello, everybody. My name is Marjan Sebdani. I'm going to talk about emotion classification as an NLP case. It's a project I had done before in my previous job, and I'm going to talk about that in this talk. This is my bio. I'm currently work as AI developer at DNB. And before joining DNB, I was data scientist at Publicis Media, and I have a PhD of electrical engineering from Siemens Institute of Technology. During this talk, I'm going to talk about the emotion classification. What is emotion classification? Data set I was using, and the NLP models I am implementing, and the results. First, what is emotion classifications? Emotion or emotion mining refers to all areas of detecting, analyzing, evaluating human toward different issues, events, service, and any other tests. You might see in the text, you might see in tweet, comments, and you have a reaction regarding to text. Or every text or tweet or comment might have emotion inside that. And this project, it just focuses on the text emotion mining or text emotion classification. I'm just trying to extract emotion coming from a text. Or you might see, for example, ad content and you have a emotion regarding to that. You have a reaction to that ad. I'm just focused on that to extract that emotion. Every text or every sentence can have multiple emotion. One, when you look at the text or tweets, you might have a multiple emotion regarding to that text, or you might see different emotion inside the text. I'm just trying to find the presence or absence of emotion in that text. That the emotion I'm talking about is anger, joy, sadness, or extra. Every text or every tweet might have emotion inside, or you might get the feedback from the user regarding to that text, and you have labels for the text. If you have a label for the text, that shows that the emotion regarding to that text is called supervised learning. If you are familiar with the machine learning, you know that the supervised learning has three parts. The first one, when you have just two classes and you are trying to predict this is positive or negative, this is true or false or something. The second one is the multi-class classification. You have set of classes, you have set of the labels, and you're just trying to find it one of the label as an output of the for example, class output of the classification. For example, if you have a text, you're just trying to show that, for example, one emotion as a output as a representative of the text. Or another thing is the multi-label classification. You have multi-label, and you're trying to show that several labels as the output of the text. For example, you might have satisfied or happy with the text. You might have both of them for the text. In this talk, I'm just focusing on the multi-label classification. I'm trying to create a model to do classification and find a multi-label for that. In my project, I had used the data set coming from the company, but I cannot show the data set. So I've found it a data set from the University of Alberta, which is very, very close to the data set. I have it. This is called CBET data set, actually, clean, balanced, emotional tweets. And it includes 81,164 rows or records. For every record, we have ID text and 9 column as emotion. And emotion they consider is anger, fear, joy, love, sadness, surprise, thankfulness, disgust, and guilt. I know that some of you might say that, okay, this emotion is very close to each other and we can combine it. It's possible you can combine this emotion and make it at least shorter, but I just keep it as it is. And this is very ideal data set. You don't have this kind of the data set in reality. I didn't have this kind of the data set. This is very clean, very balanced, and if you look at this data set, is more than 3% of that has at least one emotion. This is a sample of the data set. I have it. Like, for example, you see the several texts here and several emotions regarding to that text. Some of them has at sign, some of them has emoji sign, some of them has like a question mark. And for each one, you see different emotion regarding to that. For some of them, it's very easy to find. For example, thanks for meeting, surprise from the best people in the world, birthday, hashtag birthday, hashtag birthday party. We definitely have love and surprise label as a label. For some others, doesn't have anything. And we are trying to create a model to classify these texts. As I told you, this is very, very ideal data set. If you do break down the labels, you see that you have 10% of the emotion for in your data set. This is very ideal. In reality, you don't have this kind of data set. And you can see that it has joy or love together, fear or love together, love or surprise, and others together. For any data set, before it started, you need to find it if this is a balance, imbalance data set, if they have a labels which cover all the data, all the rules, and if not, for example, you just might find it one label repeated in all the records, and you have 100% of the one label. Definitely, you need to remove that kind of the label because it just add complexity to your model. It doesn't add any information to your model, or if you find it that your data set is imbalanced, you need to find it, how balanced is each one. Like for each label, you need to find if it is as enough sample for each label or not. If you need to do some down sampling or up sampling, you can do this for that label. But for my data set, because as I told you, this is very, very clean data set, it's not necessary to use this part. And also the last part to do train and test the split. In this third section, I'm going to talk about the NLP model I was using for this project. I want to show that which one is work best and why. I consider three solutions or three models for this project. First one is classic NLP model, very simple one. You can use it a TF-IDF for vectorization, and you can use it XGBoost for classifier. The second one is a recurrent neural network, and I was using GLOBE for vectorization, for globe embedding for vectorization, and LSTM for classification. And the last part is a BERT. I was just trying to retrain a BERT on my data set. The first one is classic NLP. For any NLP project, you need to do some cleaning before starting anything. You need to remove common words, stop, which is called stop word. You need to, for example, if you know that it has an at sign, you need to remove at sign. If it has like a hash sign, you need to remove hash sign. If it doesn't necessarily, it doesn't add any information, you can remove that. If it has like a common word, you need to remove that. And all of them can be done by NLTK packages. NLTK is a very famous package in Python. And also you can reduce the word to stems. After you have done cleaning, the next step is you need to convert the sentence to break to words, to token. Actually, token here means that two words, actually words. You have a sentence and you need to have a vector of the word. And tokenization happen here. And the next step is after you create a vector of the word, you need to convert it to number related to those words, because you cannot use it as a feature until you get the number for those words. So for the vectorization, I'm using TF-IDF. TF-IDF is standing for 10 frequency inverse document frequency. Is a statistical model trying to find it how frequency word is in document over how frequency word is in corpus. Corpus includes several documents. And if you have something like there or that in your document, definitely you have it in the corpus as well. And because it's trying to calculated logarithm of this value, it's going to be 0, and it doesn't have any value, any high number for the below that in your matrix. But if you have just one word which is important for you, it's going to have more weights in your matrix. When you created a matrix of numbers for your input, you need to have a classifier for that. I'm using XGBoost. XGBoost actually is standing for extreme gradient boost centers. It's creating to improve decision tree performance because decision tree has a problem like overfitting problem, and XGBoost created to add a gradient boost tree, to trees, so just fix this problem. It works in many cases. I'll use it here to show what happened. Another thing is that because we want to find it multi-label classifier, we want to create a multi-label classifier, and all of the machine learning classifier is based on the multi-class or binary class. You need to convert it multi-label to one versus first or one versus others, like a train one label for each, train one model for each label, and convert it back to the to binary classifier, or power cell. You need to convert it your transfer to multi-class classifier. Otherwise, you cannot get the multiple label from your model. This is the first model I used. The second model I was using is LSTM. For the LSTM, also I'm using the NLP package to remove common words and also reduce word to stem. And because I'm using Keras, I had a chance to use a tokenizer from Keras to tokenize a sentence. For the vectorization, instead of using TF-IDF, I wanted to use a new model here. And for that purpose, I'm using a pre-trained word representation here. For pre-trained word representation, you can have a context-free or contextual pre-trained representation. In this case, I was using context-free pre-trained representation, which is called GLOBE. GLOBE stands for Global Word Representation. It's from Stanford, and it's context-free. It generates a single word embedding representation for every word. It just generated like one vector of the numbers for every word regarding to all possible word to word combination. And it creates a vector of the number for each word. But the problem here, it doesn't take care of the context here, and it just creates it for every word. But the good point is here, if you have something like a man and king, you have very close number vector of the number for them, because these two words is very close to each other, and it created a meaningful number of the vector of the numbers for you. I was using Globe 6300 here, which contains the 100 dimension embedding vector for 400,000 words. So it's coming from dictionary, actually. And after creating the matrix of the numbers here, I need to use one classifier. I was using LSTM. LSTM is a special case of a recurrent neural network. LSTM and RNN, actually, both of them is created to extract pattern sequence data, such as time series data or text data. And LSTM is trying to fix the problem. We already had it with RNN. Like RNN had a problem with long sequence data, but the LSTM trying by adding one more unit to that to solve this problem. But you cannot have a better performance if you increase the number of the layer for LSTM. 2 or 3 layers is enough for us, but I just use one layer here. This is our critics of the layer I'm using. I just had one input layer, one embedding layer, and one embedding layer for the globe, actually, and one LSTM layer with 128 neurons, and one dense layer to representing 9 output for 9 neurons. Actually, in this case, you can have it one model for each of the labels and calculate the probability based on the sigmoid function at the end, or you can have it one model with the 9 output. Both of them works here. This is a LSTM summary. I'm just using that this LSTM summary, and the third method I was using is the BERT. It's a very famous method. It's just published in the paper in 2018 by Google, and there's a contextual model and generate a representation of each word that is based on other words in the sentence. They're trying to create a model, create a word, create a numeric representation for word based on the left side of the word, right side of the word, based on the deep look when you look deep the word in the sentence. It's trying to create it in relation to all the other words in the sentence. It doesn't just based on the, for example, just based on the left side of the word. It's trying to find it any combination of word and trying to find it the probability of any combination of word and create a vector for that. BERT stands for bidirectional encoder representation from transformers. And one of the good case of the BERT is that if you do Google and search for example, for example, something like Visa American travel to Brazil, two here is very important for BERT, and I'm trying to just showing you the results of visa requirement you needed to travel to Brazil based on the two, just based on the two, and it doesn't show that otherwise it doesn't show that the visa requirement for Brazilian to travel to US. So BERT is able to understand the context of queries, include common like a 2 and 4, in which it was not able before. Before it just shows into both sides, both from Brazil to US and from US. So this is very important feature of the BERT. I'm trying to use a BERT as a motion classifier. So BERT has an opportunity to we can do tokenization, cleaning, stemming, removing words inside that, and also you can retrain your model based on the BERT and fine tune it based on your data. You already have it, and it's gonna show you one versus all results, but because I had just a CPU for in my home laptop, it takes 1 day to process, to train my data. It's very long comparing to other two methods. It's very long, but I think it's worth to use the BERT and to evaluate your results. So after I ran it three methods, three model on my text, on my input, I show you how the result is good. For a classic NLP, which I just use TF-IDF and XGBoost here, I had a very, very poor result. XGBoost is really good for any kind of the model, any kind of the, for example, for time series, for any kind of the machine question, machine project. But for this case, I didn't get a very good result. It's just less than 50%. And even I use a grid search, I didn't find it a better result here. The result was not improved for me. And I also use a PCA to, if this has if I have a feature problem, I do reduce the feature dimension, but it doesn't help me in this case as well. So this is a label, an XGBoost label. You can see that in some cases work, in some cases doesn't work. It's 50-50 actually. And for LSTM also, I didn't get the good result here. It's just accuracy very, very low compared to BERT actually. And even I try to use a 3 epoch, but if I use more epoch, it doesn't change anything, and it doesn't good. So this is a result of the LSTM for me. You see that in some cases trying to predict, but some cases not good results. It's not showing that good result here. But the BERT, it's showing that very, very powerful result. Is really good here. I trying to calculate the accuracy for each of the labels, and you see that this is really good result here for me. And eval loss is actually 21%. This is very high number compared to two other results. And if you look at the Takes, if you look at the table here for label and birth results, you can see that it's trying to predict very well. It's just better than two other methods. And in my case, I decided, okay, BERT is much better than the other two other methods, but it's actually expensive because you needed to run it for at least 1 day for 81,000 data. If you have a just CPU, it takes time actually, and it depends on you. You can use one of them, but in my case, I use a BERT here. This is the references I was using for my project, and thank you for attention.
If anyone has questions, you can throw them into the chat box and we'll address them. Okay, well, it doesn't look like any questions today. Marjan, thank you so much for joining us. That was great. I know everyone.
Thank you for having
Everyone's
me.
giving you a huge round of applause. We can't hear it, but it's there.
Thank you for having me.
Yeah, thank you again, and thank you everyone for joining this session. Feel free to make your way to the next session, browse our booths, take a one-on-one meeting, and we will see you at your next one. Thanks, everyone. Bye.